Welcome back, distillers, brewers, hobbyists, winemakers, and those of you who are just curious about what we're doing. I'm George, and today is Distilling Day. So we're going to take a really slow approach and walk through an entire distillation. You can tell I've got my pint jar. That's for collecting the methanol in the very beginning. I'm going to show you all that. So I'm not quite sure yet how many parts this will be, but understand it probably will not be just one take, only because it'll be a while. I made a mistake yesterday, and that's when we wired up our 240 volt, 220 volt, whatever you want to call it, from our panel, our circuit breaker panel. I kept calling it a fuse for some reason. This is a circuit breaker, not a fuse. Although in my mind it kind of does the same thing. Circuit breaker trips off, and whenever it hits that amperage level where it's unsafe, it clicks off on its own, and a fuse just blows, and you got to replace the fuse. So I use it interchangeably. So that's my mistake for the end of this year, and I just wanted to share that with you. Now, don't forget to subscribe if you haven't done so, and share us with your friends. Join the almost 28,000 other subscribers in our community, and please comment below so we can stay in touch. Otherwise, you can call me. There's my phone number. And in the interest of transparency, if you really have a hard time getting in touch with me, george.duncan76@gmail.com. I'll answer your questions, or we can open up a dialogue. Either way. So now what I've got to do is I've got to get everything ready, and it'll take me just a few minutes, and I'll tell you what else I'm going to do. I'm going to put a clock on the wall back here so you can track the time it takes for me to do certain things. But just understand that the total time for this is going to probably be most of the day. Look, I'm retired and I got all day to do something, so guess how long it takes me? Yep, all day. But I want to walk through this slowly, and we'll explain a lot of tips and tricks and some science and some things that are really interesting and things that you need to know. So we're going to distill, we're going to filter, and then we may flavor a little bit, but we're also going to start the aging process and by putting it in a wooden cask. By golly, we got a lot to do today, so sit back, enjoy, and let's get with it. What I have here is 5 gallons of blueberry mead. And this is a finished product, but this blueberry mead has a little bit of an aftertaste to it that we can't get rid of. So instead of just dumping this, we're going to distill it. So this will shorten our process a little bit because we don't have to go through any fermentation. This is already ready. This is also proof that mash does not go bad. Here's our first tip. Now, in order for a mash to turn to vinegar, 2 things have to happen. One, it has to be open to the atmosphere with oxygen. And 2, you need the Acetobacter virus, or it's just another microbe that will invade that, because remember, yeast will eat sugar, and the byproduct, it will produce alcohol. Your Acetobacter will eat the alcohol and produce vinegar. So in order for that to happen, you've got to make the environment correct for that. Just like you have to add yeast in order to make the alcohol. You're going to have something in there to eat the alcohol to produce the vinegar. And trust me, that doesn't take 3 days. And I've heard everything from, well, you get your mash finished and you got to do it within a day or 2 or it turns to vinegar. Well, it's impossible. It just doesn't happen. And for those out there who disagree with me, look, I understand. We'll respectfully disagree. But a lot of people say, well, it turned to vinegar because it tastes sour. Well, it's supposed to taste sour. There's no more sugar left. That's one way of testing it, is just to taste it. And if your mash is sour, all the sugar's gone. So the only thing left is alcohol and, of course, the water. So I just wanted to share that with you. I've had this sitting here for Oh my goodness, it's probably been sitting here. I got 2 5-gallon buckets full that's been sealed and sitting out here in the shop for about 3 or 4 months. I've let them sit as long as 6 months until I get to them, even a regular mash. So please understand that it's not going to go bad. I get that question all the time. You can make your mash and let it sit until you get to it. It's not going anywhere. All right, on to other things. By the way, that mash or that mead that we're going to get ready to run, tested out at about 14.5% alcohol by volume, ABV. Now remember, that's a data point for me, and I'll share that with you. It tells us a whole lot about how our run is going to progress. So we can use that data point to predict where some of our cuts should take place. And I'll show you all of that. Now, we're going to use the 8-gallon still because I've got a 5-gallon bucket of that mead, so I'm using 8-gallon still. And the reason for that is that I need enough headspace. So never ever take an 8-gallon still and fill it with 8 gallons. It's just got an 8-gallon capacity. But I would never put more than 6 gallons in there. Leave yourself that headroom so that vaporization and rise can take place. Just in case you wind up with a boil, you don't want that to work its way up your column. So give yourself that headspace. If you fill it all the way up, it'll probably work for a while, and you may have some challenges, but let's avoid all of those. And remember, there's no right way to do the wrong thing. 6 gallons is about the max. Now I'm going to use a 3-inch column, and I'm going to use both of these, and I'll explain why. 3-inch column versus a 2-inch column, of which I've got both. And the reason I'm going to use the 3-inch column is because it's a little bit more efficient than the 2-inch column. It doesn't have nothing to do with the alcohol, the proof, the strength, the flavor, or anything. It is purely an efficiency event. The purpose and the reason is because of the size of, see, I've called this circumference, I've called it diameter, I've called it everything in the past. The bottom line is that there's a lot more space in here. As a matter of fact, in a 3-inch column, there's twice the amount of space as there is in a 2-inch column. And so what that does is that allows for more vapor to travel, and it's a bit more efficient when it's on top of still, because you've got a lot more vapors that can travel. As opposed to a 2-inch column, that'll be a little bit smaller, and therefore it kind of restricts the amount of those vapors that can travel up and down your column. Because remember, you're going to get some activity that takes place in here that you can't see, but it happens. And that is, the vapors start to rise, and they tend to start to cool off a little bit, and then the most volatile substance, alcohol, continues to rise, and everything else drops back out. Now, if we were to use this as a reflux, which is another topic all in itself, we're going to run it as a pot still. We would try to force that activity to take place, which is to rise, drop, rise, drop, rise, and drop. And again, the most volatile substances continuing to rise, and those things that you really don't want to drop out. But we're not going to do that today. We're going to do just a straight standard pot still. Now, additionally, your still is very sensitive. Trust me, I understand that. I get these calls a lot as well, is that you're having a hard time managing the head temperature. And when you manage the head temperature, what you're doing is you're measuring the vapors as they exit from the column into your Liebig condenser. And this is where your distillate will come out. And of course, you got cold water goes in and cold water comes out. And you just run that full force. But what you want to do is you want to measure that vapor at the point where it transitions from straight up into the column and goes across into your condenser. And now that's where you want your vaporization point. And scientifically, it's like 173 degrees Fahrenheit. By gosh, each still is a little bit different. And where you measure makes a big difference. But please don't worry, don't get stuck. Use that as a point, as a target. But if you're measuring from here, it may be a little higher or maybe a little bit lower than if you're measuring from up here. So it all depends. So if you've got your thermometer in there, or your thermocouple, as I would use with my PID, and it starts to produce at 170, by golly, I know that now. I know that that's where that's at. That's where it produces, and that's where I'm going to keep running it. If it takes it to 180, I'll know that, well, I'll measure it at a point where 180 is the right place. So you're looking for two things. You're looking for production, and you're also looking for temperature. But you'll be in the ballpark looking for that temperature. It's not that critical. It's only critical as you match it with production. And production should be a drip, 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 pour, drip, 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 pour, drip, drip, drip. You follow me? Okay. A few more things. Now, I'm going to use this. If I used this as just a pot still on top of my 8-gallon, I would just put the Liebig condenser right here on this one piece. But what I can also do is, you see, this is the part for the reflux, and these are the tubes, the cross-sectional tubes that go through, and they also make them with a jacket. Both are just as good. They're efficient. And what this does is it pre-condenses. This would go on top, so you'd have like a 42-inch stack. Those vapors that rise, it pre-condenses those vapors and they start to drop out. And as they start to rise again, the most volatile substance, as we talked about earlier, being alcohol, rises again. And it gets past these tubes, and as it starts to pass these tubes, it starts to pre-condense and drop out again. And then it transfers into your Liebig condenser. Now, and this action takes place, it's a cycle. And what that does is it strips every bit of the flavor, strips all the fusel oils, it strips everything out of that vapor, and it produces a very, very high proof vodka or gin. That's what a reflux is designed to do. So unless you're making vodka or gin, I probably wouldn't use a reflux. So I'm going to use this, but I'm not going to connect these tubes. I'm just going to use it as an extra long column so that I can stand next to it and talk with you at the same time as things are going on in here. And also I'm giving myself plenty of time for all those vapors to travel up and travel across. So now 42 inches, I've been asked this. The shortest is probably somewhere around 18 to 20 inches for a short stack, or just a standard pot still if you're going to use a column. 42 to 45 or so, 46 inches is probably about your max. Remember, there's a point of no return where efficiency, distance, and size will become an enemy. So keep that in mind. All right, let's move on. We've got a few more things to cover. The column, as I was going to say earlier, it's very, very sensitive. And it's also, I've had people call and say, George, I can't maintain the temperature. It keeps fluctuating up and down. Well, if you're outside in a breeze and you got a breeze going across, that's going to cool this column. If you got a heater next to it, it's going to heat the column. If you open the door, shut the door, this thing is your still is very, very sensitive, and it's looking for a sweet spot. And so it's going to react. So what I'm going to do, and I've recommended this to other people, you can do this many, many different ways. You can, wrap fiberglass around it, some insulation or whatever you can. I've got some pipe wrap, and I'm just going to pipe wrap these so that just in case my heater pops on or I need that out here, and I've got that current of air flowing across it, it doesn't affect the overall temperature. All right, good enough. Now I'm going to start wrapping this up, and we'll be right back. Well, we've got these things wrapped. Now this tape, this is just regular pipe tape, and it's a foam insulation with silver on the back. It's a tacky side to it that wraps around, so it comes off real easy. So don't worry about it sticking to your columns. But it's a really good thing to have. Is it absolutely necessary? No, absolutely not. So I've got them both wrapped, and I'm also going. Here's what I used. It's called MD pipe wrap, and it's 2 inches wide by 30 foot long. I think I paid like $10 for it, and it is rated up to 200 degrees Fahrenheit. So we should not reach 200 degrees Fahrenheit in this column. Well, we might. We might just rate up, because 204 is my shutoff for head temperature. And a lot of times it'll be less than that, because I will shut my still down based on temperature, production, and proof. Some folks will go all the way down as far as like 60 proof. Now, remember, when you're down to 60 proof, it's 30% alcohol, so that means 70% of what's coming out is going to be from the wash itself, water and all those other fusel oils and things. I will usually shut mine off at probably 100 proof, maybe 90, but it all depends on what the production is going to be like. Now, additionally, for those who are concerned about having copper in your system, and I know there's a long litany of discussion about whether it's absolutely necessary or not. I'm of the opinion that it's better to have and not need than need and not have. I have not found a difference between using it and not using it, with the exception of it is a packing which increases the proof because it increases the efficiency of your column. So if you have just a straight column, all you get is the vapor. It condenses and comes out. Very little activity takes place in there. But if you put scrubbers in, and this is like 24 inches of copper mesh. Now you can use copper mesh, you can use marbles, you can use rashing rings, you can use pennies. And remember, I think it's pre-1964 pennies are 99.9% copper. You can bend those and stick them and put a handful of those in there. It's readily available. So you can reuse these over and over again. As soon as you're done, pull them out, rinse them off. If they have a little odor to them, put some vinegar and water, just let them soak for a little while, rinse them off, they'll be fine. You can use them over and over and over again. Now, here's the interesting thing about packing. For every 4 inches of packing that you put into a column remember, a plate is a physical thing, and it's also a measurement. So think about that. If you have and you've seen some of those stills where you have a big window here and windows that go up. Those are, of course, they're real expensive. They're usually 4-inch columns to 6 to 8-inch columns, but they got the big windows. And inside you'll see what's called a bubble plate. And it's normally made of copper. Some are made of stainless steel. But what this bubble plate does is this bubble plate gives that distillate an opportunity to rise, condense, drop, bounce around and bubble, most volatile substances released, and the non-wanted substances continue to drop and redistill until it finally drops back into the kettle. But so you'll have multiple plates which actually strip all the flavor, strip everything out of it, make a very high proof, very good distillate, and very clean. So that's a plate. And each time you have a plate, it correlates to a distillation. Think about this. If you've ever picked up a bottle and it said triple distilled, now let me ask this question from an efficiency standpoint. I already know the answer, but from an efficiency standpoint and from a production level, cost and overhead, do you truly believe that someone is taking a substance, distilling it, putting it back in, distilling it, and putting it back in and distilling it? Is that possible? Well, yeah, that is possible, but every time you distill it, remember, you got a really high alcohol content. You've got to cut it. You put it back in the kettle, you cut it, and you bring it back down to a manageable level, which is, somewhere right around 30, maybe 30 to 35% ABV, and then you run it again, and then you do the same, then you run it again. All right, there's another alternative to that, and that is plates. So if I have 1, 2, 3 plates in my column, then I'm actually distilling the equivalent of 3 times. It kind of begs the question, can I legally say that? Yeah, absolutely, because that's just the way it works out. So for every 4 inches of packing that you place in there, it's equivalent to a plate. So when I put these 2 in here, I'm actually going to distill twice. Plus the initial would be 3 times distilled. No, I got that one backwards. I'm sorry. Yeah, it would be twice distilled. So I can call this a twice distilled spirit, and that's perfectly okay. Now, to pack these, they should be loosely packed. And once you get them in, and of course you got to have a screen in the bottom of it or some sort of device to keep it from dropping in the kettle. Once you place them in there, the way to test it to make sure, and this includes whether you're using rashing rings, whether you're using marbles or the pennies or whatever medium you're using, if you want to make sure that you've got them in and it's correctly packed, is if you can breathe through it. If you can breathe through the pipe, then it's packed correctly. If you have any problem breathing through the pipe, it's packed too tight. And you just have to pull them back out, loosen it up a little bit, and throw them back in there. All right. We're getting ready to put this puppy together, and I've got a few other things that I wanted to cover, and let's do that right now. Because remember we talked about, let me set these aside for right now, and this is my tri-clamp and gaskets. And we're going to talk about that. Remember that data point we had, the 14.5% or so? We're going to call it 15. Just for the sake of argument, we're going to give ourselves that extra 0.5%. And we're going to do the real quick math, and I'm going to show you how to determine the volume of which you can anticipate and what the cuts could potentially be. Stick with us. Now, let's do some real quick math. Remember I told you about that data point, that 15% ABV? I'm going to show you why that is a very important figure, and it can tell us a whole lot. Let's go slowly. You ready? We've got 5 gallons of mead. Now, every gallon has 128 ounces. So 5 times 128 equals 640 ounces. That is like about 19 liters. Now remember, and I'm actually rounding these off just to make them simple. Now if we multiplied that, because 15% of that is alcohol, of that 640 ounces, by 0.15, 15%, that means we've got 96 ounces of alcohol in our still. Or like 3 liters. Now let's take that 96 ounces from there, because we know that's how much alcohol we have, but that would be pure alcohol, and we're not going to be running pure alcohol. We're going to probably run this at about 80% efficiency, which would be like 160 proof. So if we multiply that by 0.80, we know we're only going to get about 80% of that alcohol, because the rest of it's going to be lay dormant inside. That would actually equal 76.8 ounces, or 2.3 liters. Now, here comes the good part. We're going to really know a whole lot more than just this. We know that 76.8 ounces is our 80% efficiency level if we reach that. And that's sort of like just a target. If we take that 76.8 ounces, and we know that when it comes out, 40% of that or so, because it's 160, about 160 proof is sort of like my target. 40% of that, we've got to add the water that's going to drag along with it during its process. So if we multiply that times 0.40, that means of that, not of that, but in addition to the 76.8, we were going to add 30.7 ounces of water, or 0.9 liters. See, in this one here, of course, yeah, 2.3 liters. All right, we're just about there. So if we take that 76.8 ounces, and you can round this off, just say 70 or 77, and we add that to the water we're anticipating, 30.7 ounces, which is 0.9 liters, and this is 2.3 liters, gives us a grand total of 107.52 ounces, or 3.18 liters. Guess what? That is what I anticipate drawing off the still. That's actually 0.8 gallons. So I'm going to collect about just shy of a gallon. And I always say that, anytime you draw 3 quarts off of a 5-gallon batch, you've done really well. But remember, this figure is always going to be connected to this figure, your ABV. Your alcohol by volume will always indicate what your potential volume will be when you're finished. And remember, this is going to be at, and I'm guessing at 160 proof, which is 80% alcohol. And of course, we're going to cut that down. So this 0.8 gallons is going to turn into, and I'm going to take a stab at this, is going to turn into probably about 1 3/4 gallons. Or as I like to say, 7 good quarts of smooth goodness, and a lot of fun later on you can share. I hope that really makes a lot of sense, because that's as simple as it really gets. Now, one last thing of that, I'm going to show you this. We'll use this same sheet of paper here. The heads, the foreshots and heads that I always collect together, I believe that they come out together, is going to probably be somewhere around, probably 2 to 5 ounces. And, well, how do you test that? Well, you just take a spoon, get you a couple of drops at the very beginning of your run, and we'll do that. Light it, and if it burns yellow, it is methanol. You continue to do that until when you put a couple of drops in there and you light it, it's either transparent or blue, and you've got ethanol. So that means all your foreshots and the majority of your heads are gone. Now, the heads do, let's just, for sake of argument, I always put foreshots and heads together. Now we're getting into our hearts. About the last 10% of your run is going to be your tails. And so I'll know that I'll take 10% off of this. I'll take 10% off of that. And I'll know that probably about, maybe 0.2 gallons, or maybe a pint or so, I know are going to be tails. I know that. But when I get to about, 3/4 of a gallon, a little over half a gallon, that's when I'll start sensing, tasting, and smelling for my tails. So I know that I've got plenty of time in the beginning. I can just run and run and run until I get to about a half a gallon, a little over half a gallon. Then I'm going to start testing real closely to make sure that I don't mix the tails with my run. I really hope that makes sense. Let me lay this up one more time, and if you'd like to, you can just go ahead and ponder over that. If not, let's move on. We're wrapping up now, and we're getting ready to get started. Now, I know it's been a slow process, but we want to explain as much as we possibly can as we go through this process. And we got a lot to cover later, so we're going to do a part 2. So make sure you stay tuned. Here is what I've got. I've got a cooler here, and I've put about 25 pounds of ice in it, filled it with water, and I'm going to use that for the condenser. I'll put it around here somewhere. I found it. All right, this is going to be the Liebig condenser that I attached to the top of the still. And cold water goes in the bottom hole, and it comes out the top. And that way, so it cools from here all the way back and goes back into the cooler. Now, here's the reason why I use ice. Please, it's not absolutely necessary. I know that I'm going to run this. It's going to take me a couple of hours to run this. Now, I could use just regular cool tap water, but if I use cool tap water, I'm running that for, what, 2 or 3 hours. Why don't I just recycle the water? So if I get it super cooled with ice, as that water goes in and it will heat up. It will come out warm. Later on, as the water warms, it will come out hot. So, because it's dissipating all that heat that's going to be in that condenser. So what that'll do is my ice will eventually melt, and the water will start to feel a little bit warm. It's not like tepid, you know. You can stick your finger in there, you'll feel it's getting a little bit warmer. I've got the exit hose will be extremely long. You just lay inside here, and what I'll do is I'll pull that hose out and I'll stick it out the door. Let that hot water escape, go outside. I'll refill it with some more water while it's running, and I'll throw about another 20 pounds of ice in it. So I can do it with 30, 40 pounds of ice easily, and it's going to run me about $3. So that's the only reason why we use ice water. We don't use ice water for any other reason than to preserve water, the amount that I use, because I'll only go through maybe 2 of these, and I don't have to run water constantly all the time. I'll also use my Parrot, and what my Parrot is just a device that goes on the end that gives you high cool points when your friends come over. You're like, yeah, check this out. You'll put your proof and trail hydrometer inside here, and as it fills, so here's the escape hole. If you ever make one of these, make sure you put the vent up the top, or else you'll have challenges. It'll back up on you. So my spirits will run in here, and they'll start to fill from the bottom to the top, and then they'll come over the top into this cup and then run back out into my jar, my collection jar. I'll use this after I collect the first 2 to 5 ounces and check to make sure that I'm running ethanol instead of methanol. But what will happen is that my proof and trail hydrometer will float there, and it'll give me a data point instantaneous to what the still's producing. So I'll always be able to tell. And see, that's another one of those. I know that I'm going to start off at about 160 proof. And remember, we did the math. There's nothing precise about that. It's just a good ballpark figure. So it gives me some ideas of time that I have and what I've got to do. So I'll track that, because I'll start off at about 160, maybe 165. Who knows? It depends on how efficient my process is. Now that will progressively start to drop, and my head temperature will progressively start to rise, because it will take more heat to separate that alcohol from the mash, because the volume in the mash is changing. So therefore, when that changes, its boiling point changes, and the temperature, of course, is going to have to start to rise. So I never go over 204, and I rarely go under 100 proof. 92 sometimes, but I'll rarely go under 100 proof. So we've got those data points. We're anticipating 0.8 gallons, minus just a little bit. So, 3/4 of a gallon makes me a happy camper. And of course, we're going to go through the process of cutting that. We're going to go through the process of filtering it, and then we're going to start the aging process. So I got a whole lot of day left, and it's going to take me the rest of the day. So stay tuned. Part two's coming up, and we'll be with you. Happy distilling.